Hi folks, it's Mr. Mudalich here with another video. This time we're looking at a brief summary of factoring. So I've broken down factoring into two parts. Today we're just looking at the essence. I'm going to try to make this video pretty short, so around 10 minutes, and we'll go from there. Okay, so when you think of factoring back from grade 10, one of the first questions you want to ask yourself whenever you're doing a factoring question is a great place to start is there a greatest common factor? And what is that from my of my terms, right? So what's the GCF? Then you kind of want to think about, some other questions to ask yourself is like thinking about how many terms are there. If there's two terms, am I dealing with a difference of squares? And then likewise, if it's three terms, is it a trinomial, right? If there's no greatest common factor, if it's not a difference of squares, then maybe look at, is it a trinomial? Is it a perfect square? Is it a simple trinomial? Is it a complex trinomial? We'll kind of go over those today, okay? All right, so those are the things that you want to ask yourself. Let's start with the most basic type of factoring, which is common factoring, right? So here I have a question, right? The thing that divides into both is a 5x, so I factor out a 5x, meaning I divide each of these terms. Remember, a term is something that is split by things that are multiplied and split by pluses or minuses. So this is my term 1, this is my term 2. So I divide out a 5x from each. So 10x divided by 5x is 2, and then negative 15x squared divided by 5x is negative 3x, right? If I multiply this out, I would get the original. So this is now factored. I can't go any further. Okay. For question B, right here, my common factor is 9x squared y because it happens in at least once in each term. Then, similar to before, I just divide each one by 9x squared y, and I get the underlined like that one right there. Okay, moving on. Here, I could see each, when I'm common factoring, and even if I have three terms, I'm kind of looking at, okay, well, that's a 6, 12, and 3. So 3, the number part 3 goes into each, it's a factor. Then I'll look at the C's and see which is the smallest that, the factor of C that goes into each one, at least once. So then it'd be C squared. And then, yeah, there's at least a D in each one, so D. So 3C squared D is going to be my greatest common factor. And then I'll just divide each term. I'll look term by term, starting with this one, and I'll see how many times does 3C squared D go into this. Well, it goes exactly 2C times, because if I multiply those two, I get this out, right? The opposite of multiplying is dividing. So when we're factoring, it's like we're kind of dividing this by this greatest common factor to get 2C. Right here, we're dividing negative 12C squared D squared by 3C squared D to get negative 4D. And likewise, 3C cubed, okay? All right, this one's an interesting one because sometimes our greatest common factor doesn't always have to be a term. It is still a term, but it doesn't always have to just be a block of things being multiplied like this and like this. Sometimes it could be literally an expression, which is like a jumble of terms like this, like literally x plus 2. Because again, I'm looking at these two, and I'm looking at, okay, what is the greatest common factor? What is the thing that happens in both? Well, it's that x plus 2 term right there, that factor. So I factor out an x plus 2. It's just a group, that's okay. But you could see the remnants after I do that. When I divide this term by x plus 2, because I pulled it out, I'm left with an x. That's this. When I divide this term right here by x plus 2, I'm left with negative 4. So this is my factored expression. All right, so I've written it down here as well. All right, that's common factoring. That's the basics of that. Next, we get to difference of squares. What I need you to know is that a difference of squares looks like this, right? A squared minus b squared. So it's something that's like square rootable. I don't know if that's a word, but something that you could take the square root of, that's my a squared, and then it's always minus, and then something that you could take the square root of, that's my b squared. If I have an expression in that format that looks like that, then I can rewrite this in factored form as a minus b times a plus b. That's how I factor that, right? Because if I expanded this, I'd get a squared plus ab minus ab. That's how the middle, the two ab terms, they cancel out because one's positive, one's negative, and then minus b squared. So difference of squares. Right, here's a bunch of examples on difference of squares. Notice that this one right here is not factorable because, it's tempting to write x plus 8, x minus 8, but I can't do that because this is a plus here. It only works when it's a difference. So if that was a minus, I could factor, but it's not. So this one right here, yeah, just notice which one's your a squared and b squared, and then go ahead and find a and b. So in this case, a would be x, b would be 9 square root of 81. So then I write x minus 9, x plus 9. They're all very similar, right? This one's my a squared, so my a would be square root of this, so 3x. Square root of this is 5, so then I get 3x minus 5, 3x plus 5. Square root, actually here, before taking the square root, because I immediately, I circled it, and I was like, okay, take the square root of this, and then I see a 2 here, it's not square rootable, so I don't want to common factor that. But then I realized, okay, well, there's a 2 here, and there's a 2 here, so then I'm looking at both terms, and I realized, oh, I could common factor first, so common factor of 2, and then this one is more, difference of squares, so I'm able to take the square root. So x minus 11, x plus 11. All right, so here my a squared is here like an expression, like an actual a larger expression. That's okay. This is my, the a would be 2x minus 1 and the b would be 7, right? Square root of 49. So it's going to be a minus b, a plus b. And then I just simplify this, right? I take out the, I remove the brackets and kind of just collect like terms. So 2x minus 8, 2x plus 8. I can factor out a 2 from each, right? Generally, sometimes we could keep going. So then I factored out 2 from the first one. I get this. Factored out 2 from here, and I get this. And so then I combine the 2 and times 2 is 4, and then x minus 4 and x plus 3. Okay, that one's a good one. Here, my a is going to be the square root of that, so 4x squared, because the square root of x4 is x squared, square root of 16 is 4, and then minus y2. So I'm going to write 4x squared minus y2, 4x squared plus y2. So that's good. Now notice that this term right here, I could still go ahead with factoring that out, because again, it's another difference of squares, because that's square rootable and this is square rootable. So the square root of that would be 2x, so I have 2x minus y, because the square root of this is y, and then 2x plus y. So that was this. And then I just rewrite this. I can't factor that anymore because there's a plus here. And there's no common factor. So that's it. That's what that looks like. Okay, so that's difference of squares. Moving on here, I get things that are like this. So now I'm looking at trinomials. Okay, so trinomials, I have two cases. I have simple trinomials. That's when the coefficient of the x squared is 1. And then I have complex trinomials and perfect squares as well, but complex trinomials where the a value, the coefficient of my x squared is not equal to 1, right? So in both cases, you're going to want to use M.A.N, but, however, in complex trinomials, we have another option as well, but a good starting point would be for M.A.N. For simple trinomials, that is the preferred method, okay? So the M.A.N method, it means you're looking at two numbers that multiply to, well, this is a 1, right? So technically it's like 1 times 24, but since for simple trinomials, you're just looking at the last number anyways. So you're looking at two numbers that multiply to give 24, that add to 11. And so what are my two numbers? 8 and 3. And then I just write x plus 8, x plus 3 for this simple trinomial. Here it's very similar. I'll let you have a look at these. So here my two numbers are -4 and -10, so I just write d minus 4, d minus 10. Here, remember, you can always common factor. Please do that if you can. So I factor it at 2, and then this becomes a simple trinomial, and then I'm looking at, okay, well, what are my two numbers that multiply to -35 and add to 2? They have to be +7, -5, so I get something like this. Here, I get my two numbers are 12 and -3. So I write it like this. Just be careful here, folks, because notice here, I have an x squared, so I know it's going to be an x and an x in the beginning. Here I have a y squared. So I need to have like the number 12 and -3, but I need to add y's at the end as well, because that's how in the middle I'm going to get x and y as well, right? It's going to be the middle has to add up to 9, but it's going to be, the coefficient is 9, but it's going to be 9xy. If I don't include the y, then I'm just factoring, I'm factoring something like this. If I don't include the y's. Let me just write it here. So if I don't include the y's, I would be factoring something like this, 9x minus 36. And then the factor, if I factored that, yes, this would be x plus 12, x minus 3. Notice that the only difference is the addition of this y here means that I get these as factors. So just something to be a little bit wary about, okay? Just looking at, okay, what is the square root of that thing? That's, you know, y squared, so it needs to be y and y. Yes, okay. Similar situation here. I have an x4, so I need an x squared and an x squared, and then the rest should be fine because there's no y's or anything like that. But I'm just looking at my two numbers here, -9 and 2. So -9 and 2, this could, you know, I can difference the squares that. So right there. Okay, so that's simple trinomials, the M.A.N method. Now we get to complex trinomials. All right, so this one's, I said 10 minutes, but I want to spend a little bit of time here, but not too much, because it's very similar, but just there's two methods here, two ways to go about this. So complex trinomials and perfect squares. Again, a is not equal to 1. Let's consider this example right here, right? I want to show you two ways to do this. You could use decomposition. This is what you most likely learned in grade 10. Or you could use M.A.N with a twist. There is whichever one you prefer. Decomposition, you are using M.A.N, and this time you're looking at two numbers that multiply to a and c. So the first, the coefficient of x squared and the coefficient of that constant. So in this case, it would be 14, and they add to this middle number 15. So my two numbers would be 14 and 1, right? The other option would be 2 and 7, like 2 times 7, but they don't add to 15, so I have to use 14 and 1. So that works, and then I decompose. So this 15x, I'm going to write as 14x plus 1x. That's what decomposition is. And then I factor by grouping. So factor by grouping means it's when I have 4 terms, I'm going to group the first 2 and the last 2. And by the way, it does not matter if you write this as 2x squared plus 1x plus 14x plus 7. So if you swap the order here, it would still work, okay? So here, now I'm going to common factor something from here. So that's going to be a 2x. I get this. Common factor, I can't common factor anything. It's just a 1. So I just write that. But now I'm going to see that I can common factor again, right? I have an x plus 7. So when I do that, I'm left with 2x plus 1. So this is my answer for that complex trinomial, this original question, by using the decomposition method. Okay? All right. Let's take a look at M.A.N with a twist. So same question with M.A.N with a twist. I'm starting off the same. I'm looking at what are my two numbers that, well, they multiply 7 and 2 multiply to give 14, add to give 15, and the two numbers are 14 and 1. So that's good. Now I want to take each of these answers that I got and divide each one by a. Okay, but dividing in a very special way. So I literally write it as a fraction. So 14 divided by 2, and I want to reduce this. I want to always reduce this if possible, so the fraction. So I'm going to literally write 7 over 1. So that's what I now care about for that first bracket that I'm going to write. Okay, 7 over 1. The second one, the answer was 1, so I'm just going to write 1 divided by 2. I don't want to write a decimal. I don't want to simplify it. I need to keep it as a fraction. This now contains all the information I need to write my two factors, my two brackets. So I know that my answer is going to be, you know, a binomial times a binomial. The numbers on the top of like my two fractions that got are going to be the constants. So the part that comes at the end. Just like, you know, we'd expect when we get the number answer from using M.A.N in any way, those answers go at the, well, not in this case, but typically, right, in here, -9 plus 2, the answer came right here, -9 plus 2, right? For simple trinomials, it just goes with the last two numbers. They go right there, right? And then I have to add, well, here, y, but you get the idea. The numbers just go straight to the end. In this case, it's similar. It's very much the same. The numbers just go at the end, so plus 7 and plus 1 at the numerators. Now the denominators are my coefficients for that same respective bracket, right? So let's say here, so I'm just trying to look here. Yeah, okay, sorry. These arrows are making it seem a little bit confusing, but yeah, okay, there we go. All right, so yes, actually no, what did I do there? Okay, so let me erase this arrow and this arrow. There you go. That makes it a little bit more clear. If you take a look here, like this first fraction, well, the 7 went to the end here, and the 1 became the coefficient of my x. So that's how I get that first term. Here in the second one, the 1 goes at the end right here, and the 2 becomes the coefficient of my x. So it's always going to be like that, okay, for M.A.N with a twist. These next few questions I've done with M.A.N with a twist. I would like you to take a look at them and kind of study it. You could also use decomposition, but just because, you know, it's good to practice, like keep it consistent with M.A.N, we stuck to that method. But really, you're looking at, okay, well, 3 and negative 12, multiply to negative 36, add to negative 5. My two numbers, negative 9 and 4. I'm going to divide each one by 3. So for the first one, I get this fraction, negative 3 over 1. For the second one, I get 4 over 3. When I'm writing my answer, I'll do bracket and bracket. And then, so for this first pair of brackets, I'll have, so let me write it here again, actually, just to make it a little bit easier, just to annotate this while I'm speaking. So then I would write, so I'd have bracket and bracket. For the first set of brackets, I'd have, so I'll do x and x here, and then I'd have a minus 3 coming from this numerator right here, and the coefficient of that would be, of the x would be 1. I don't need to write that, coming from the denominator 1. The coefficient of my, sorry, not the coefficient, the numerator is a 4, so then I'd have a plus 4 here, and the coefficient would be a 3, so I'd have a 3x plus 4. So that's how that works, folks. Just be a little bit conscious about that, okay? And that's how we got this. If you keep going, you'll see that it's very much the same. What I need to comment about this is, yeah, just multiply, add numbers, and then make sure to divide. And I've highlighted here just to show you where these numbers are coming from. Here, it's like similar to before. There's a y term at the end here, so don't forget to add the y's at the end. Here, if you can common factor, you want to do that first, and then it becomes a complex trinomial that you can use M.A.N on, and you get these two terms. This last one right here is an example of one that where if you were gonna use M.A.N with a twist, you know, the M.A.N method, you're like the two numbers that multiply would be really big, and they add to another big number, so it would take a while to figure out what those two factors are, the two numbers that, you know, allow that. When that's the case, more often than not, this is probably going to be like a perfect square trinomial. So this is what you need to know. A perfect square trinomial always looks like this. So it's always a squared minus 2ab plus b squared. That'll factor into a minus b squared. Or you're going to get the same thing with the positive version. So a squared plus 2ab plus b squared. That would factor into a plus b squared, right? If you literally expanded this, you would get this. If I expanded this, I would get this, right? That's where it's coming from. So that's the form when you see something like that. Next thing you need to know is about square numbers. So these in high school, typically these are the square numbers that you are expected to know, up to 15 times 15, right? 1 times 1 is 1, 2 times 2 is 4, right? 13 times 13 is 169, just so you can recognize these. And then the next thing you want to do is know when to use the perfect square trinomial factorization. Well, if let's say I'm given a question like this, right? 4x squared plus 15x plus 9. These first two terms look that like I could take the square root of them. So I might write 2x plus 3 like that, and maybe put a squared because this is a plus here, and put a plus here. And this is actually, so this is not actually factorable into this, even though it looks like it is, because that middle term isn't what we want it to be. Because if I took, right, this is a squared, this is a 2x, and if this is my c squared, this is my c value, or sorry, my b value. I'm just a plus, I'm trying to get a plus b squared, right? So that's my a squared and that's my b squared. But the idea here is that, like, you know, if I doubled this and this, the product, I would get 12x, which is not the same as 15x, because I need it to be 15x for it to, I need it to be 12x for it to be written as a perfect square, for this to be a perfect square. So compare this with, if I had 4x squared plus 12x plus 9, then I could write this as 2x plus 3 all squared. Okay, so that would be a perfect square trinomial. All right, the question now was this. So I'm going to square root this first part, so that's going to be 7x. Square root this part, that's going to be 5. So I got my a and b. Let me write this as, so since it's a negative, I'm going to write this as, a minus b squared. But first, before I do that, let me actually check if this is a perfect square, right? I'm going to do negative 2ab because this is the one with the negative here. So it's like this type of perfect square right there. And then I'm going to do double 2ab. So I'm going to get negative 2, and my a is going to be 7x, my b is 5. I multiply everything out, and I get negative 70x, which is in fact what I have in the middle. So this is a perfect square, and I can write this as 7x minus 5 all squared. So that's how I work with perfect squares. All right, folks, here is your homework for this lesson. It's a handout, and it's these questions from the handout. So here's the handout right here. It's good because it's grouped into, the different sections. So common factoring, difference of squares, quadratic, so simple, trinomials, complex trinomials, and these are the answers to those questions. So go ahead and give that a shot. Thank you and have a great day.